My name is Nicole.
My name is Ale.
My name is Annika.
My name is Annika.
And my name is Diego.
But first of all, what is a piecewise function? A piecewise function has at least two different equations or pieces that form it, each of them with a different domain and range. Piecewise functions have a variety of forms. It could be a linear function or a combination of other equations, such as constant, quadratic, cubic, square root, cube root, exponential, and others. It does not exist a basic function because a piecewise is conformed by multiple ones, but there's a format that must be followed. I'll show you next. So basically the function you must follow, it's very easy. It's f of x or y equals to, you open a crochet and you put inside all the equations you want to add on the piecewise function. So this is a piecewise function we're gonna solve. We're gonna solve first the first equation and then the next one. So here's how you solve the first one.
Here you have a quadratic function which forms a parabola that has a reflection on the x-axis, has two horizontal moves to the left and three shifts upwards, only if x is minus or equal to minus 3. The domain is x belongs to minus infinity, not included, till minus 3, not included, and the range is y that belongs to minus infinity, not included, to 3, included. One of the roots of this formula, or the x-intersection, is minus 3.73, 0, because y doesn't have a intersection in this parabola.
Alright, we have our function, which is f for x, it's equal to 4, with the condition of x is bigger than minus 3, but smaller than 2. So, what we're gonna do first is graph. We can see that the only value that it's given is 4. So we're gonna draw our line in the value of 4 in the y-axis. So now we're gonna enlarge our line from minus 3 in the x-axis to the value of 2 positive in the x-axis. In the edges of the line, we're gonna leave a circle that is empty. Why? Because there is no sign of equality in the condition. So we're just gonna leave it empty. So, moving on, we're about to calculate the domain. The domain will be x is equal to minus 3 to 2, seeing that are the only values that our rect has, and the range would be only the value of 4 because it's the only value that our rect has. Now, if we're looking for the intersections, in the x-axis there would be no intersections because the line never touches the x-axis. And in the y-axis there would be one intersection, that would be 4. 0, 4. And that's how our graphic.
The last equation we have to graph is minus x plus 1 if x is greater or equal to 2. This graph, or this equation, is an absolute value, which means it takes the shape of a V with a slope of 1. Now we have to transform to put it on the graph. The first step is plus 1, which means it moves up 1 point on the y-axis. Then we look at the negative sign outside of the absolute value, which is a negative, meaning there's a reflection on the x-axis. Now we have to look at the limitations, which says that x has to be greater or equal to 2. This means the line starts from 2 and goes on into infinity.
This is how our piecewise function will result if we graph it on a computer. If you can see it's the same ones that we did on the board. We did each of them individually, but at the end it's all of them in one single function, as we can see over here.
In conclusion, all the team members learned how to solve these piecewise functions based on what we researched for this project and what we learned in class. We also learned how to relate these exercises to daily life problems, like the paying of bills and more. Thanks to this project, we will know how to solve these problems in our lives in an easier and much faster way by using all the steps we learned and explained in this video. That's why we believe the topic of this project was very important to know about and understand, as it can be used again in our future.